Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In an S_N1 reaction, the rate-determining step is formation of a carbocation intermediate. Rearrangement, hydride or methyl shift, occurs when a more stable carbocation can be formed from the initially generated carbocation. Rearrangement is favored when the carbocation that would initially form can rearrange to a more stable, higher substituted or resonance-stabilized carbocation. Moving on to the next step. The structure is 3,3-dimethyl 2-iodobutane CH3C CH3 2CH ICH3. Ionization of the Ci bond gives a secondary carbocation at C2. Adjacent to it is C3, which is a tertiary carbon bearing two methyl groups. A1, 2-hydride or 1,2-methyl shift from C3 to C2 converts the secondary carbocation into a tertiary carbocation, neopentyl to tertiary type rearrangement. Rearrangement occurs. Moving on to the next step. 1-chloro-2-methylcyclohexane. Ionization gives a secondary carbocation at C1 of the cyclohexane ring. Adjacent C2 bears a methyl substituent and is also secondary on the ring, but a 1,2-hydride shift from C2 to C1 would give a carbocation at C2 that is still secondary. However, C2 also has a methyl group, so after the shift the carbocation at C2 is actually a tertiary carbocation, ring carbon C2 now connected to C1C3 and the methyl group. Thus rearrangement occurs to give a more stable tertiary carbocation. And for the final step, 3-iodocyclohexane. The iodide is on the allylic position, C3 of cyclohexene. Ionization gives an allylic carbocation that is delocalized over C3 and C1, the allylic system, which is resonance stabilized. While the initial carbocation is already stabilized by resonance, the allylic system itself represents a form of rearrangement of electron density, resonance structures, and in practice allylic carbocations can lead to rearranged products via attack at either end of the allylic system. This constitutes rearrangement in the product distribution. Since all three options, A, B, and C, involve S_N1 intermediates that undergo rearrangement to more stable carbocations, the answer is D, all of these. Therefore, the correct answer is D. Therefore, the correct answer is option D.